Hello, my name's Caden.
And I'm Cole.
So this is our video for our final project for ECE 3710. And so we decided to build a scrolling jump game, and we implemented it on our STM32 microcontroller with a 7219 matrix LED bar.
Yep, the inspiration for this game was the Chrome dinosaur game that you find yourself always playing when you don't have Wi-Fi access. So we thought it'd be great if, even if you didn't have a browser, to be able to plug it into your computer and be able to play it at any time.
So as an outline of this video, first we'll go over the gameplay, how the final product works, which will be taken by Cole, and then I will show the circuit diagram and the physical hardware with a little more explanation, and then Cole will go over the uh, the software side of things.
Sweet, let's get into it. Hello, this is the gameplay for our microcontroller final project. This is the begin frame that the game initializes with. If we just click the reset, you'll notice that it flashes and then it comes back on. The red button is to start the game, so we'll click that. And then it makes an audible tone, the little jingle that we have. And then you'll see that the objects begin to cascade across the screen. And when I press the green button, the character jumps over the objects. I can press it at any time. I can hold down. And then the objects start to scream across the screen a lot faster as the game advances. And then you'll notice when we hit one of the objects, we get the game over screen and the score screen, and then that bar represents the score of our playthrough. And then when we click the reset button, it starts over to the begin screen.
So this is our circuit diagram. So we have our microcontroller in the middle, and then we have our inputs, which is our two different buttons, and then we have our outputs. So right here is our 7219 LED matrix that are set up in a cascading formation. And then we have our buzzer on the top. And we have a small resistor just to make sure that we don't damage the buzzer. You'll notice that we have a separate power that goes into our LED matrix, as well as DN, CS, and clock all cascade through the different circuits. So we have our physical circuit here. So you'll notice that these pins down here, and they are connected to each other along solder bridges, and so the information can make it to the whole thing. And this is the whole circuit.
Welcome to the code review with Cole. Here we have our Microvision tile project pulled up with our main.c file, our startup file, and our STM file, which are standard with a lot of our EC3710 projects. These are all of our function declarations for our project, and then this is where our main function begins. Here we have declared and initialized all of the variables in our program. The frame is sent as an array of 8 integers, which represents 1 for each row of 32 LEDs. So we thought that was the easiest way to send those in. This is where we set up the MSI clock at MSI range 7, which is 8 megahertz. This is where we enable the clock for GPIO B and C. This is where we update the mode register for pins 0 and 1 for the buttons as input, and pin 2 as output for the piezoelectric buzzer. Then we set the GPIO pin 0 and pin 1 to pull up, so we get information from the IDR. And this is where we set the mode register of the GPIO-C to output. This is where we initialize our max 7219 LED matrix, and then we enter our while loop. This is where the while loop begins. Here we get the information from the GPIO-B IDR. That's information from the buttons if they're pressed or not, which updates the button mask there. Here we have our switch statement, which is determined by our state. Here in our first state, case 0, we get a game start function that updates our frame, and then we send that frame as parameter to our print function, which parses it into the 4 individual 8x8 LED matrices And then we have our if statement, which asks if the button is pressed. If it is, then we advance our state and we get our little buzz jingle there. Here we have our next state. So when the button is pressed, it moves on to clear the display. And then if our button is pressed, then if button mask equals 1, then we update our jump variable. This jump variable is passed in as a parameter to our player position function, which determines where the player is at in their jump and then updates the frame array and returns it to int main. And then otherwise jump is decremented every time you move through the while loop and sent for each frame. It's updated for each frame. Here we have our delay and our count function. What those do is simply determine the speed of the objects as well as the distance when distance increments. So when count equals object speed begins at 7, and over time it decrements. But here we have distance get a random number, and that distance determines the distance between the player and the objects approaching the player. So here this object position function updates the frame with the object approaching the player, and then it's printed. The frame is printed to the LED matrix. So basically, what the frame is updated first with the player position and then the object position. And then here we have our condition, our end game condition. So if the player is below the height of the object, and if the distance between the player and the object is small enough, then we advance to our game over state and we get a sad buzz. Otherwise, if the distance is 2 and the count is 0, which means that the player successfully jumped over the object, and we get a happy buzz and our score increments. Here we have a delay function that allows it to be a little bit more playable. And then our last state is our game over state, where we pass in the score as a parameter, and then that gets printed to the screen. Here are all of our print functions there. They're all pretty simple. The last print function clocks our CS high and then low, which sends all the information to the LED matrix. This is where we initialize the LED matrix. We have a clear display function there. We have our height function, which shows initialization frames for each position of our character. Here we have the object position. So our object starts on the right side of the screen, and then it's shifted over depending on distance passed as a parameter. Then we have the game start, which is just begin question mark spelled out on this frame, and that updates the frame, game frame. And then our game over frame, which is just game over. And then the score, which is just written here. And then that passes to our score function, which updates the score bar for the player. Here we have a delay function. Here's our print function that parses the frame out to the individual print functions. There's our random variable function there. Our buzz functions, and then our score, which just updates a bar depending on how big the score was by the time the player finally stopped. So, yep, that's pretty much the code for our final project.
Welcome to the final project review. This is where we talk about how the project relates to the project proposal that we had written. We originally wanted to use the LCD in our project proposal, but we saw another group use the LED matrix, and we decided that that would make more sense for a game that we wanted to make. And so we switched that out with the LED matrix. But the other components, the buttons and the pencil buzzer and the game behavior, are all the exact same as proposed in our project proposal. So that's basically all of our project thus far. Thank you for watching.
Thank you.
We'll see you later.